Welcome back everyone. My name is Sagar and we are back here with another video. So today is day 192 of our POTD series and today this question name is transform to sum tree and this is given a very easy question. So if you are practicing enough questions on tree and recursion then most probably you already have solved this question. So first of all we are given a binary tree of size n and we are given the root node of that tree and where each node can have positive or negative values. Okay, we can have positive and negative values. So we have to convert this tree into a tree where value of each node will be the sum of all the values of the nodes in the left and right subtree. So that means we have to replace this value. So first of all, this is given our tree. Okay, let me just draw it here. So this is given our root. So this is our root, है ना? And after that there is a left tree, there is a right tree. So there is whole left subtree, right? And there is a whole right subtree. So first of all, we have to replace some value x from here, and we have to remove that value, and we have to add this whole subtree sum and this whole subtree sum, and we have to place the sum here. Okay. So we have to get all the values from our left subtree and all the values from our right subtree, and we have to sum it and place it in the root. Okay. So we have to do the exact same thing for all the nodes. For this node also, it will have some left node, it will have some right node, and we have to do the exact same thing. And after that, what do we have to do? The value of the leaf nodes are changed to 0. Okay. So if we are at some leaf node, then that is obvious also. So if we are at leaf node, then there is no left and there is no right. So what we will do, we will just return 0 from here and 0 from here. So we have to add both the sum of both the values. So we will just place 0. And also we have to return the original value. Okay. So that the parent of this node, so this will get the original value. Okay. And now that is a very simple question. So first of all, what we have to do? First of all, we will just DFS and we have to return here int. And why am I returning an integer? And that is because we have to need the sum. So for our this 10 value. So let me just draw this example. So first of all, root is here 10 and then minus 2. Here it is 6 and 8 minus 4 and 7 5. So there are these nodes, okay? And first of all, what we have to do? First of all, we will DFS, means that first. So first of all, we will check this node, root node, okay? Sorry, this leaf node. So first of all, this have no left value and no right value. So first of all, we have to place here 0. And from here, we have to return 8. So what we will do? First of all, we will return this sum. So that is the whole sum, okay? From our left node plus our right node plus our this value. So first of all, we will just return the sum from our recursive function. So what we have to return? 8 plus 0 plus 0 and 0 0 is the sum from our children values of this node. Okay. So 8 plus 0 plus 0. So first of all, we will just return 8 here. And when we are calling recursive function to this, for this node, we will just return 8. And for our this value, for our right value, we have to return minus 4. But for this node, we have to place here 0, and that is because it have no left value, it have no right value, so it will return 0 and it will return 0, and we will place the sum here, and at last we have to return the whole sum, that is minus 4 plus 0 plus 0. Okay, I hope now you understand this. And for this minus 2 value, what we have to now write? So we will just replace this minus 2 value. So it was here minus 2, and we have to place here 8 plus minus 4. So it will be here 8 minus 4, that is 4. So 4 will be placed here, that is this value minus this value, or this value plus this value. So it will be here 4. And at last, what we have to return? This 4, that is the sum of the children values of this node and plus the value of this node. So we have to return here from this node, what we have to return? 8 minus 4 minus 2. So we have to return the whole total sum value, that is the data of this node or the sum of children. And I hope now you got this. We have to do the exact same thing from here. So it will be here 0, it will be here 0, 0 here, and it will be also 0 here, and we have to return from here 7. From here we will return 5, and we will just place the sum here. So what is the sum? 12. So we will just write here 12, and we will from here we will return 12 plus 6. So 6 was the data of this node and the sum of the children will be 12. So 12 plus 6 we have to return, and now we have to place here 12 plus 6. So this is our left, this is our right subtree sum, this is our left subtree sum. So we will add this value and place it here, and at last we will return the whole sum. Okay. So we don't need that whole tree sum, so we will just ignore this, and that is why we are ignoring here. And this is a void function, so we don't have to return anything. And our DFS function is integer, so you can see it is here returning integer, so we have to return some particular value, that is the sum of children node, children tree, children subtree. Okay. And this is your node. And what is the base case? So first of all, we are writing a recursive function, so we have to write the base case. So if we are here, so if we are doing the first for this value and this is a null value, so if our root value is equal to null, then what we have to return? We have to return here 0, obviously. So that means we will return some 0 value to our leaf node, and that is a very simple thing. Root equal to null, then we will return 0. Else what we have to do? First of all, we have to now replace this value. So suppose there was some value 8 here, and now we have to remove this 8 and place all the sum of children values. Okay. So we have to now remove this 8. So we have to remove this, and that's why we have to first store this before removing. So before removing, we have to store this also. So what we will do, we will just store val equal to root dot data. So we just stored that value, and we will now get the sum of left children and right children. So we will just do the DFS left equal to DFS root dot left. So this DFS function will return us the sum of our left subtree, and we will just store it. Okay. And we will just do the exact same thing. Okay, let me zoom it. So we will just do the exact same thing, and let me make a space. So we will just paste here right sum. So we will just store it in our right t, and we will pass here root dot right. So we will also get the sum of our right subtree and store it in this variable. And after that, what we have to do, we will just update root dot data equal to left subtree sum plus right subtree sum, and that is it. We have to replace the original data with this value, and after that, what we have to return? We have to return the whole sum, that is the previous data which was stored in this value plus left subtree sum plus right subtree sum, because that is the thing we want for our parent node. Okay. So we are just returning the whole sum of subtree, and that is it. So let me just now check this. So the time complexity is here. So we are traversing in our whole tree only one time, and we are using the here recursion. So the space complexity is O of h. So that is it. That was the expected time and space complexity, and our algorithm is now working. So if you like this video, if you understand the approach clearly, then do like this video and also subscribe to our channel. Only 80%, only 20% of the viewers are subscriber to the channel, and 80% are just viewing the video. Okay, so do subscribe to our channel, everyone, and you will get this solution in our DSA repository. So that is it for today, everyone. Do like this video and subscribe to the channel. Thank you for watching.